Welcome to PRISCI-ANTO Educational Academy, Chennai. Today I am going to explain you the introduction of Laplace transform. Laplace, the name who invented this transform. Transformation. What is the meaning of transformation? It's a mathematical tool. Transformation is a mathematical tool which converts one function into another function. So, the definition of Laplace transform is Laplace transform of f of t or L of f of t, which is equal to integral 0 to infinity e power minus st f of t dt, where s is the parameter, t is always greater than or equal to 0. Here, the existence of Laplace transform, there is some conditions, two conditions. So first condition, f of t, this f of t should be of exponential order. Second condition is f of t should be of continuous or piecewise continuous in the given period. Okay, so these two conditions are very important to solve the Laplace transform problems. Let us see some problems. Number one, find L of e power at, Laplace transform of e power at. First, you have to write the formula. L of f of t is equal to integral over the limit 0 to infinity e power minus st f of t dt. This is the formula. What we are going to find L of e power at. So L of e power at is equal to integral over the limit 0 to infinity e power minus st. Instead of f of t, here is e power at. Instead of f of t, e power at. So where is f of t in the formula? You have to substitute e power at. So L of e power at is equal to integral 0 to infinity e power minus st e power at into dt. In the next step, you have to write integral over the limit 0 to infinity e power minus, I have taken as common. So e power minus of st minus at into dt. So minus, if you multiply inside the two terms, e power minus st plus at, e power minus st plus at. Okay, so base are equal, you can add the power. So that's why I added the power as well as I have taken minus as common. So e power minus within bracket st minus at into dt. T is common in two terms, st and the at. So therefore, integral over the limit 0 to infinity e power minus of s minus at, s minus a, t is common, s minus at dt. So you have to integrate. Integration of e power ax dx, which is equal to e power ax divided by a. The coefficient of x you have to write in the denominator. Here also, the coefficient of t you have to write in the denominator. So e power minus of s minus a into t divided by minus of s minus a, because t is the coefficient of t is minus of s minus a. The limit is 0 to infinity. So you have to apply upper limit as well as lower limit. First I apply upper limit infinity. So e power minus s minus at, if you apply t is equal to infinity, e power minus infinity divided by minus of s minus a, minus, if you apply t is equal to 0, e power 0 divided by minus of s minus a. So e power minus infinity value is 0, e power minus infinity value is 0, e power 0 value is 1. So first term will vanish, will be 0, second term will be minus divided by minus will be plus. So 1 divided by e power 0, 1. 1 divided by s minus a. L of e power at is equal to 1 divided by s minus a. L of e power minus at, if here is minus, L of e power minus at means answer is 1 divided by s plus a. E power at is positive, answer will be in negative. E power at is in negative, the answer will be positive. Okay. So you have to keep in your mind. Let us see second problem. Find L of cos at and L of sin at. Laplace transform of cos at, Laplace transform of sin at. In Laplace transform, first you have to write definition of Laplace transform. L of f of t is equal to integral over the limit 0 to infinity e power minus st f of t dt. Here we have to know e power iat can be written as cos at plus I sin at. That is the formula. E power iat can be written as cos at plus I sin at. So both, I'm going to take the Laplace transform to the left hand side, L of e power iat, which is equal to integral 0 to infinity e power minus st into e power iat, because L of e power iat instead of f of t, here is e power iat. So e power iat into dt. In the next step, you can write as base are equal e, power is minus st plus iat. So minus I am taking as a common, as we studied in the previous example. So which is equal to integral 0 to infinity e power minus of s minus ia into t into dt, which is equal to e power minus of s minus ia into t divided by minus of s minus ia. So integral, we are integrating. So the coefficient of t should be written in the denominator, minus of s minus ia. The limit is 0 to infinity. First you have to apply the upper limit minus lower limit. E power minus infinity, the first term will be 0. Minus e power 0 is 1. 1 divided by s minus ia. So L of e power iat is equal to 1 divided by s minus ia. So I am multiplying and divide by, if you are taking complex conjugate, s minus ia is there. So you have to multiply and divide by s plus ia. So s plus ia divided by s minus ia into s plus ia. You know very well, denominator is s minus ia, s plus ia. If you multiply a, you will get s square plus a square. So therefore, L of e power at, which is equal to s plus ia divided by s square plus a square. So L of what is e power iat? Cos at plus I sin at. So Laplace transform of cos at plus I sin at is equal to, this can be separated into two parts. S divided by s square plus a square is the real part, plus I into a divided by s square plus a square is imaginary part. So L of cos at plus I into L of sin at, which is equal to s divided by s square plus a square plus I into a divided by s square plus a square. So comparing left hand side as well as right hand side, you can easily conclude that L of cos at is equal to s divided by s square plus a square. L of sin at is equal to a divided by s square plus a square. So this is the answer for L of cos at. So you must keep in mind, when we are going to solve the Laplace transformation problems, it needs, right? So we have to keep in our mind while we are solving the Laplace transform problems. These are the formulas of Laplace transforms. Next question is, find L of t. So L of t is equal to, so we can easily find, as I already explained you, the Laplace transform definition is L of f of t is equal to integral 0 to integral over the limit 0 to infinity e power minus st f of t dt. L of t is equal to, instead of f of t, in the problem we have to find t. So for f of t you have to write t into e power minus st into dt. So this can be solved using the Bernoulli's formula. Integral uv dx is equal to uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus etc. U is equal to t. U dash is equal to, if you are differentiating t, you will get to 1. U double dash is equal to 0. V is equal to e power minus st. V1 is equal to e power minus st divided by minus s. You have to integrate it. V2 is equal to e power minus st divided by s square. So from, if you are using the formula uv1 minus u dash v2, so therefore L of t is equal to uv1 t into e power minus st divided by minus s minus u dash v2. U dash is 1, v2 is e power minus st divided by s square. Limit is 0 to infinity. So if you apply infinity upper limit, both term will be 0. If you apply lower limit, first term will be 0, second term will be minus e power 0 divided by s square. So minus of minus, because when you apply the lower limit, there will be another minus sign. So minus of minus e power 0 divided by s square. E power 0 is 1. So 1 by s square. L of t is equal to 1 divided by s square. So these are the formulas we have to keep in our mind. So thank you.